lecture, I think we have considered the derivation of integrated equation for the first order reaction, rate constant, and zero order reaction, rate constant. And previous lecture also we have studied order of reaction, molecularity of reaction. But in that lecture only definitions were considered. In this lecture, zero order reaction, first order reaction and second order reaction you have to study. Okay. So let us consider once again order of reaction. What is order of reaction? I told order of reaction is related to the number of moles whose concentration changes with respect to time. And molecularity of reaction also I told it is the total number of molecules involved in chemical reaction. Whether the concentration changes or not doesn't matter. It must be balanced chemical equation. Okay. So the sum of powers of concentration terms in the rate equation is called order of reaction. Rate is equal to K A raised to A B raised to B, where A is capital A square bracket is molar concentration of reactant, molar concentration of reactant B, and small a we have the numerical coefficient, that is number of moles. If you sum the numerical coefficient power, that is order of reaction is A plus B. It is the sum addition of numerical coefficient, but concentration must be changed. Okay. So order of reaction is always determined experimentally. Theoretically, we can't determine order of reaction. Molecular order of reaction, we can. It is the balanced chemical equation. Whether the concentration changes or not doesn't matter. We have to count total number of molecules. Okay. So that is the difference. It is always determined experimentally. Theoretically, order of reaction cannot be determined. Okay. Now, as I told, there are three types of reaction, order of reaction: zero order reaction, first order reaction, and second order reaction. What is zero order reaction? The reaction in which rate of the reaction is independent of the concentration of the reactant is called a zero order reaction. Okay, independent of initial concentration. Let us have the example. Ammonia decomposes to give nitrogen and hydrogen in presence of catalyst, platinum or iron. As on providing the reactant, it will take place continuously. Therefore, rate is independent of initial concentration. Second example, hydrogen chlorine combination in presence of sunlight gives hydrochloric acid. This is also continuous process. As and how you provide hydrogen and chlorine in presence of sunlight, reaction will take place continuously, independent of initial concentration. One more, decomposition of hydrogen iodide in presence of gold catalyst, it gives hydrogen and iodine continuously. So all photochemical reaction and catalytic reactions are zero order reaction because it provides energy to decompose or to form the product as and how the reactants is provided continuously. Understand? So important are the reaction, photochemical reaction and catalytic reaction usually are zero order reaction. Understand? Secondly, first order reaction. First power, the reaction in which only one reactant molecule concentration alters. Only one molecule reactant concentration changes is called first order reaction. Okay. Example, nitrogen pentoxide gives nitrogen dioxide and half molecule of oxygen. Here only one molecule is there. Therefore, order of reaction is 1. Hydrogen peroxide decomposition gives water and oxygen. Only one reactant is there. order of reaction is 1. Ammonium nitrate, N2 plus 2H2O. Here only one reactant is there, so it is the first order reaction. Now here, third one, second order reaction. The reaction in which two reacting molecules concentration alters is called second order reaction. Two molecules are changing concentration as time passes. Example, hydrogen and iodine gives HI. One molecule, two. Concentration changes, therefore it is a second order reaction. Here 2 molecule is 1, but number of moles are 2. Therefore it is a second order reaction. The power of concentration term whose concentration changes. So how many numbers are there? 2. Therefore order of reaction is 2. Here ester methyl acetate, sodium hydroxide, 1 1 1 plus 1 2. So two reacting molecules are changing concentration. Therefore it is a second order reaction. Okay. Lastly, once again molecular reaction. The total number of molecules of the reactants involved in chemical reaction is called molecularity of reaction. Only thing is whether the concentration changes or not doesn't matter. We have to count total number of molecules involved in a chemical reaction. So this is important. Definition example from the point of examination, both order of reaction and molecularity of reaction. One more thing, for 2 marks, usually question asks, write any two differences between molecularity of reaction and order of reaction. Okay, so what you have to write? You have to make 2 columns, order and molecularity. First of all, definition, order of reaction, the sum of power of concentration term involved in chemical reaction. Molecularity, total number of molecules involved in chemical reaction. Second, order is determined experimentally. Molecularity always determined by balanced chemical equation. Third, order may be 0, it may be fraction or it may be whole number. But molecularity of reaction, it is always a whole number, 1, 2, 3, like that, not fraction. Okay, so we'll stop here. In next class, we have derivation, half-life period for zero order reaction, and relationship between half-life period and rate constant for zero order reaction and first order reaction. Okay, we'll stop.